we usually think about immunity as protection against infection. Of course it is, but immunity is also protection against cancer. The best thing you can do to prevent cancer is to upregulate your immune system. So to treat cancers, we need to increase the T cytotoxic cells, the killer cells, and reduce the activity of the regulator cells. And he says there's a problem here, that there's a lack of immunologists in cancer. Now, coincidentally, we had a long conversation with Professor Clancy, Professor of Immunology, of course, on this very topic yesterday. So do try and watch that video. Very, very enlightening. So lack of immunologists. So cancer doctors often aren't quite realising of course, they're clever doctors, but we need more on the immunology, because there seems to be an immune deficit, an immunosuppression at the moment, which is leading to these increased numbers of cancers. And cancer, Dr. Soon-Shiong said, is everything about immunity. Pretty strong word for a doctor. Everything about immunity, because we get cancer every day. So now a lot of people are out of equilibrium. Their immune system is out of equilibrium. Is this due to ultra-processed foods? Is it due to infections? It's certainly as a result of chronic inflammation. So this is a key thing. Chronic inflammation will very often lead to cancer. Chronic inflammation will very often lead to cancer. What is there in our environment that could be leading to chronic inflammation? Ultra-processed foods could, of course. Infections could be. Abnormal immune reactions could be. Ongoing production of particular pathogenic proteins could be leading to chronic inflammation. I'm being careful not to put words in Dr. Soon-Shiong's mouth here. I'm just trying to restrict myself to what they actually said. But that's the key thing. Chronic inflammation causes cancer. No question about that. And with prolonged inflammation, the neutrophils. So neutrophils are cells which eat bacteria. They're sometimes called macrophages. They're phagocytic cells. They will eat. They're antibacterial cells. So when you have a bacterial infection, your neutrophils will go up. You'll get more neutrophils. But he said this, and I didn't know this. I had no idea about this. But he said with prolonged inflammation, the neutrophils can go from cells that eat bacteria, they can flip. In other words, they can transform into suppressor cells. So if there's prolonged inflammation, the very cells that are there to combat the inflammation, not to combat the inflammation, but to eat the bacteria that are causing the inflammation, the chronic inflammation can cause these to flip into suppressor cells. And he calls this, again, this is this yin and yang idea. So for every cell, there's sort of an equal and opposite cell to give this equilibrium. It's kind of a seesaw, isn't it? He talks about a yin and yang. And he talks about a term he's invented here called quantum oncotherapeutics. Now, what the heck does that mean? Well, onco, of course, is cancer. ONCO, cancer. Therapeutics is to treat cancer. Now, quantum is the idea. This goes to sort of Schrodinger's cat, because apologies to quantum physicists, but quantum particles can exist in two states simultaneously. It doesn't make any sense. That's the whole point about quantum physics. It doesn't make sense. So the idea is that Schrodinger, famous physicist, expanded up from a particle to a cat, and he said if you have a box with a cat in, that cat can be both dead and alive at the same time. That's the paradox. So what he's talking about is these cells. What he means is there's particular cells, and the cells can be in two states or change from one state to the other. So a cell like the neutrophils, which were protecting us, can flip into another state, into a suppressor cell. That's what he means by quantum orthotherapeutics, that a cell can be in two states. Not at the same time, but it can change quickly, and probably change quickly within a few hours. So cells in two types of cells. We talked about killer cells, suppressor cells. For each cell, there's an equal and opposite cell. That's how we keep in equilibrium. That's how so we want to be in equilibrium. We want to kill cancers. We want to kill infections, but we don't want to be reacting to every pollen grain that we come across, or every foreign protein. We don't want to be reacting to peanuts all the time. We need this balance. And he gave an example here. M1 macrophages will eat. So macro, big cells. Phage means to eat. The big cells, the macrophages that are derived from monocytes in the blood, they will eat, but they can be converted into M2 macrophages, which will suppress or block this response. So all these natural yin and yang, seesaw effects in the body are supposed to be in equilibrium. At the moment, in a lot of people, they seem to be knocked out of equilibrium. That's what this conversation is about, as far as I understand it, as far as we've got. And he also talks about quantum entanglement. Again, this is a quantum idea. So quantum entanglement is where, again, I'm not a physicist, but it's where one particle does something, another particle somewhere else will do the same thing at the same time, even though there's no physical connection between them, and they could be hundreds or indeed millions of miles apart. And anyway, the quantum entanglement is this idea that there's an entanglement between the killer cells and the suppressor cells, and that they can change from one to the other within minutes. This can be very quick. So it says there's a need to understand cancer cells in more detail, because cancer treatments at the moment, and I've never thought about it in these terms, but it's very interesting. He said cancer treatments, we've got surgery, radiation, chemotherapy. He said all of these things aren't wrong, but he said they're not enlightened therapies. They're all aimed at attacking suppressor cells, not enhancing the T cytotoxic cells. And then the conversation goes on to virally induced cancers. But clearly chronic inflammation and viruses are a known cause of cancer. Now, this brings us on to the development by Professor Dalgleish, where he's got a vaccine, or he's used a vaccine that is developed with others. He's trialled it. It's based on basically a bacteria from cows, Mycoplasma vaccae, and this it's just not subcutaneous, intradermal injection, which will upregulate the T cells. If you upregulate the T cells, what's that going to do to your cancer cells? Well, if you upregulate the T cells can kill the cancer cells. If you upregulate the T cells can kill the bacterially and virally, kill the bacteria and kill the virally infected cells. Thoroughly good thing. So he's got this. He's kept oncology patients alive for ages with it. Incredibly, some of his stories are quite amazing. How he's kept people alive for so long with this. He went to the Medicines and Healthcare Products Regulatory Agency in the UK. Said, this is being used now. It's safe. It's effective. Will you please license this for therapy, for therapeutic use, so that doctors can prescribe it compassionately? And Medicines and Healthcare Products Regulatory Agency refused his application. So there is a treatment that will upgrade upgrade T cytotoxic cells that will kill virally infected cells and probably kill a lot of cancers as well, but we're not allowed it. And I want that vaccine, but I'm not allowed it, and I think that's outrageous. Anyway, that's the first part of the interview there, just nearly all based on the conversation between Tucker and Dr. Patrick Soon-Shiong, just with a few extra minor thoughts from me, but I've tried not to stray too far from what they've said. That's just the first part of the conversation. I'm going to look at the next part as well later. I didn't want to do too much now for two reasons. One, if I do too much, I'll start forgetting it myself. and the other thing is it'll just be too long for one video. But that was the first part. There seems to be an outbreak of immunosuppression, so there's been perturbations of the immune systems that are leading to these aggressive turbo cancers, often in young people. I know you're screaming out for answers. What happened in the lives of these people before the cancers developed? Well, that information is not collected very much in the UK. Hopefully it will start to be collected now in the United States.